3. Into this class, we are going to quickly discuss scalar and vector quantities. Then we solve questions relating to them. Then we quickly move to. I want to start motion quickly, so I'm going to start motion this week. I'm very sure of that. So today, which is so we are going to look at scalar and vector quantity, like I said, scalar and vector quantity. So you guys will probably notice something about quantities. So we are still talking about quantities. Remember that when I was explaining quantities to you guys, I told you guys that quantities can be categorized into division of derived and fundamental, and that we also have another classification, which is scalar and vector. So that's exactly what we want to look at today. We want to look at the other classification, which is what? Scalar and vector. So the foremost definition for scalar, if I ask you guys now that what is scalar quantity, you're going to tell me that scalar quantities are quantities that have what? Magnitude. But no direction, right? And if I ask you what are vector quantities, you want to tell me that vector quantities, they have magnitude as well as direction. So when we say magnitude, what does it mean in physics? Magnitude basically means value. So when I say magnitude, it means what? Value. Value. Scalar quantities are quantities that we can attach value to. We can attach values to them. Only value. When you attach value to them, it makes sense. But when you now start talking about direction, it makes no sense. Let me give you an example. Mass. Example. Mass. If I tell you that the mass of person A is 50 kilograms on the surface of the earth, and I tell you that, but if you go to, okay, let's say I am 50 kilograms in London, but if I come to Nigeria, I am 70 kilograms. Does that make sense to you guys? Does that make sense? It doesn't make sense, right? For me to tell you that the mass of person A in London is 70 kilograms. But that same person A, the person's mass in Nigeria is 50 kilograms. It makes no sense. Because when we talk about mass, it doesn't make sense to describe mass with respect to what? Direction. It only makes sense to describe mass with respect to what? Magnitude. Only magnitude. So when we say mass, it only makes sense to describe mass with respect to magnitude. So magnitude is the value, the quantifying value. This 70 kilogram now is the magnitude, is the value. This 50 kilogram is the magnitude, is what value. Now, quantities that we can only describe them with respect to what? With respect to magnitude only are called what? Scalar quantities. Scalar quantities. They are quantities that we can only describe with respect to what? Magnitude only. So we have numerous examples, and I'm going to give you all the examples that will convince you. You know as I do my thing now. So the first example I'm going to give you is all fundamental quantities are what? Are scalar. all fundamental quantities are scalars. That's the first basic example, all fundamental. So it means that if you know fundamental quantities, you already know what all of them are what all fundamental quantities are scalar. Now, other examples that JAMB is going to use to confuse you, I'll bring them now. But I'll not explain them now. I'll just give you, remember Gabes theorem. Number 2, speed is scalar. Number 3, work is scalar. Number 4, energy. All forms of energy, they are scalar. Maybe kinetic, gravitational potential, potential energy, all energy are scalar. Number 5, power. Number 6, electric potential. In fact, this electric potential, you start seeing questions now, and you'll be happy that I already gave you the code. This ones, you need to know that as they are like this, that they are scalar quantities. Do you understand? And some other quantities also, but at least this one's scalar. Do you get it? Is this clear, guys? Good. Now, let's come to vector quantities. I'm also going to explain some things about vector quantities. So we will now come back to this example of scalar and we'll talk more about them. Vector quantities, they have both magnitude and direction. So when we say vector quantity, they have magnitude and they have direction. For example, if I am in this position now, I'm at this point. When we start to resolve vector now, there's some things you have to know. 4 cardinal points. This is north, this is south, this is west, and this is east. You have to know this one. Even me, I don't know how I know it, but I know that once I just pick my pen and I want to write it, I just write it like this: north, south, west, east. North, south, west, east. That's how I write it. North, south, west, east. North, south, west, east. Now, from this point, if I tell you that I move 10 kilometers east, I'm not going to be here, nor here, nor here. I'm going to be here. East. Because I already told you the position. So 10 kilometers east is different from 10 kilometers west. If you draw the map of Nigeria now, just remember how to draw this map of Nigeria. Just manage it. This place is where we are, southwest. I don't know where you are, but I'm assuming that, okay, we have somewhere in this corner is in Port Harcourt, that is in south, somewhere here. And probably we have people in other states, but we have south here. So if you go 5,000 miles to the north, it's different from going 5,000 miles to the west, to the south. You are going to get a different location. So quantities like that, it makes sense for us to describe them with what? With direction. Do you understand? It makes sense to describe them with what? In direction. Because if you change something 5 kilometers west, 10 kilometers north, they are totally different. 5 kilometers north. They are totally different. You are going to get to different place entirely. In fact, this aeroplane, they have to be on a particular bearing. If they change the bearing by 1 degree, if the bearing changes by 1 degree, with the grace of God, they are going to land in a different location. So they have to be on a particular coast. Do you understand? So look at how insignificant 1 degree can be. How insignificant it can be. But look at the cost. Do you understand? So direction is important for some quantities. That's my point. Those quantities that directions are important to are called what? Vector quantities. Is that correct? So the examples of vector quantities are now numerous. They are numerous. They are numerous. For example, displacement, number one. Displacement and distance are almost similar. Just that displacement is a vector, while distance is what? Distance is scalar. Because distance does not have what? It has no direction. Distance, the other name was for length. Just that it is the distance, it is used distance when we are talking about what? Motion. Displacement, even from elevation, it is distance traveled in a specific direction. When we say displacement, it is distance traveled in a specific direction. You can see direction is even included. So it means that displacement will be something like 5 kilometers north, 6 kilometers south. In fact, if the direction is not specified, know that displacement by default should have what? Direction. Is that clear, guys? Another very good example is velocity. Velocity is displacement over time. Now, one of the confusion that students might have in this topic is the way our teachers before explained scalar and vector quantities to us. They tell us that any quantity that has a scalar, a vector quantity is also a vector. They tell you that because velocity has displacement, that means that velocity is also vector. That can be correct in some cases, but not in all cases. For example, in the case of work, and in the case of energy, and in the case of power. Do you understand? That's why you have to understand the definition and the intuition behind why one is called scalar and why the other one is called vector. Scalar quantities are quantities that we cannot describe them with direction. That's the best definition ever. The best. That's the definition I like to give my students. Quantities that we cannot describe them with direction. That's why the first day, on the first class, I asked you guys what scalar quantities are. You said quantities that have only magnitude but no direction. I say, I was a bit skeptical about accepting that definition or not. The definition I like to give students is quantities that cannot be described with direction. We'll get back to that. Velocity is a vector quantity because that's displacement. Yes. And it also makes sense to describe velocity with what? With direction. Velocity also have a quantity that looks similar like it. A quantity that looks like it. Just like displacement has speed and displacement has distance. Velocity also has what? Speed. Speed is distance over time. You see speed, it is just like velocity. In fact, in physics, we can use both of them interchangeably. I can say speed when I mean velocity, and I can say velocity when I mean speed. So we can use them interchangeably. The only difference is that speed is a scalar. Look at the S, scalar. Velocity, V, is a vector. Because it makes sense to describe velocity with what? With direction. And it makes no sense to describe speed with what? With direction. Do you get it? Now, look at another quantity, acceleration. Acceleration is velocity over time. And it is what? It is vector. Let's come to work and is another. Before we talk about work, let's talk about force. Number 4. Force. Force is mass times acceleration. And in the definition of force, it is an agent that changes or tends to change the what? The motion of an object. And it takes place in the direction of the object. Force itself has direction inside it. Apart from that, force also has what? It has acceleration. And it makes sense to talk about the effect of force to one angle or one direction. So force is a vector quantity. Now let's talk about work. Work is force times distance. I want to believe that there's nobody in this class that does not know what work is. The definition for force, I will still talk about force. We'll still talk about force. It is an agent that changes or tends to change the motion of an object. That is force. Anything that wants to cause something to change, that is force. For example, if you open the can, that can malt, the force you need to open, that's what force. You apply force. If you go to the bank and you see on the entrance of the bank, you see push. You are not supposed to pull, my dear. If you see push, don't pull. Yeah, I will laugh at you. If you see push, push is inward. You put it in. Don't push it to yourself. Pushing to yourself is pull. Those two guys are force. And we call them contact force. You can see it has direction. I say push, you don't pull. If I say pull, don't push. Do you get it? It has direction. Where the force taking place? Do you get it? The bottom line is I'm trying to explain to you guys that force is a vector quantity. Is that correct? Are we together on the same page? Excellent. Thank you. Thank you. Thank you. Now, look at work, guys. Work is force and distance. Work has force inside it. If we go by that our definition that says that any quantity that has a vector quantity would also become vector. It means that we will be thinking that work is a vector quantity. And look at, I am here telling you that work is scalar. Now let's do that definition of force, of work. Does it make sense to describe work with direction? If I tell you that I do 50 joules of work, but this 50 joules of work is I get to London. We're not able to do 50 joules, we're just able to do 40 joules of work. It doesn't make sense to describe work with what? With direction, as well as energy, as well as power. It doesn't make sense to describe these three quantities with direction. That's why we classify them under what? Under fundamental, under scalar quantities, not vector quantities. Is that clear, guys? As well as electric potential. Electric potential new. Electric potential new. Good. Now we are like to look at questions. Hami? Are we people look at questions? Excellent. You know me now. I have questions for you. 15 solid questions. 15. Which of the following physical quantities is not a vector? Now, you have to be very careful. It's not a vector. It means that all will be vector except one, right? So velocity, in fact, the V here, was to take a vector. Work, let's hold on to work. We are coming. We'll come back. Force, vector. I already told you that one. So, vector. Electric field intensity. Electric field intensity, the electric potential. If you go and ask your brain that if anytime you see anything electric, no, it's electric potential. And I will tell you why when you see a question on electric potential. Or maybe I should tell you now. 1 minute. Now, guys, when we say electric potential, it's electric potential. It's just like work done in electricity. In fact, just like the way the other tutors are starting from a different topic from the very beginning of the topics of the subject, I intended to start from electricity with you guys. I just decided, let me just do small mechanics and go to electricity. I love electricity so much. So I want to quickly pour electricity for you guys. Then we'll now move to the, the topic that I don't like. Now, when we say electric potential, it is the work done by unit bringing a small charge from infinity to that point. That's how I would like to do it. That's how I would like to describe it. So what electric potential is telling us is just the number of energy that each coulomb charge has at a particular point. It is not a scalar quantity. Sorry, it's not a vector quantity. Because you might think that if we're talking about a particular point direction, no. Because it's talking about work done, work done. Do you understand? Work done in bringing energy connected to charge. Do you understand? So it is work. It is work. Because work done itself is a scalar quantity. Do you understand that? Now, if we now talk about electric field density, I believe what I just explained about electric potential is clear. Is it? It is not clear. Good. Now, when we say electric potential, in physics, or not even in physics, in English, when we say something has potential, what does it mean? Or any potential. This word, Amasa, we use it. Sorry?
I said ability, but you said potential.
Ability. Thank you so much. Thank you so much. Ability. That's the right word. Ability. This word, we use it a lot when we are scouting for boys that can play football or any potential. So if you go to field every day, you can raise like 200, like 500, like 1,000. You can score corner kick. You can score free kick. That any potential. Any potential. Or in school, when they ask you questions in physics, your answer any potential. You understand? So that's potential. Now, when we talk about electric potential now, this electric potential is how much energy each coulomb of charge has at a point. Energy value. So when we say the formula of electric potential is work done over charge. Do you understand? So potential to me that what ability does each coulomb of charge has at a particular point. What is the ability it has? So it is one more. It's not talking about direction. Do you understand? The scalar. But electricity, on the other hand, electrical intensity is the force. I need to know. It is force. It is force. Force. The force experience any charge placed at that point in an electric field. So it is a force. What force is a positive charge that is placed at a point to force will to electric field intensity. How intense is it? Do you understand? From the word field intensity. And in fact, when we talk about field, it's not just one point. What are the force driving it? Do you understand? So electric field intensity is vector again. So the answer here is what? Is work. So even if you all this, but you already know, I think this stuff. Understand? An example of a scalar quantity, question 2, is dash. Example of scalar. Velocity is not scalar. Wait. Let's wait first. Or wait. Electric charge is fundamental quantity. Remember? So let's hold on to everything. Attention due to gravity, you can start relation there. So you're able to us. G is what? Is out of it as well. Now, what is weight? Weight is also a type of force. Weight is a type of force. Mass times gravity. So weight is also what? Also vector. So the correct answer is electric charge. It is a fundamental quantity. Do you remember? Question 3. Which of the following is not a vector quantity? Which of the following is not a vector quantity? Vector quantity. So all are them except altitude. You know what altitude is? Weight. I tell you that weight is not. So weight is vector. So let's take it. Displacement is vector. Let's keep it. Acceleration is vector. Let's keep it. So we already take 3 vectors. I mean that this altitude is going to be our answer, right? Weight is vector. I just told you that now. Displacement is vector. I gave you in the handout. Acceleration, I also give you acceleration in the handout. Now, what's the meaning of altitude, guys? When you get to your English synonyms, the teacher is going to give you like 7 synonyms for height. Let's see if I can remember all of them. Height. Synonyms. Anyone you remember, drop it in the chat. Zenith. Altitude. Apex. Climax. Summit. I remember this.
Peak.
Is it all? Thank you. 1, 2, 3, 4, 5, 6, 7. What's the problem now? That's potential. But let's go pick and see. So all these guys are synonyms for height. Zenith, yes. Altitude, yes. Apex, yes. Climax, yes. Summit, yes. Peak, yes. So this apex was the name of our tutorial. This is what I went through to prepare for my own exam lesson. And I also taught in that tutorial. I'm supposed to tell you guys something now, but I'll not tell you. Apparently, your English teacher also went to that tutorial. She went to this tutorial as well. And we met there. We met again there and got married. Thank you. So Apex, that's not about the Apex A Academy. Apex A Academy. Okay. So zenith, altitude, apex, climax, summit, peak. Synonyms for height. So this altitude means what? Height. And what is the meaning of height? It's in physics. Now let's come to physics. Height means what? It means distance. It is just a standing distance. Distance that is standing. So in mathematics, we don't like to say height. For example, I ask you to calculate something like this. And I'll give you this one. I say it's 12. You cannot take the base and the height. This one is called base. This one is called height. Height is that standing of distance. So this was the distance. Which of the following quantities are scalars? Scalars. And good. We need only scalars. Electric potential, I will keep it. The scalar quantity. I give it one. I do not know how. You know electric potential. It's work done. Tug. If I do not tug this, momentum, it is going to be vector. Because not part of what I gave you as a scalar. So it's going to be vector. Tug to vector 2. But we don't do more tug this, but we had to momentum before, right? We've not momentum before. And I believe you guys should still be able to say one or two things about momentum. Remember that momentum and those quantities are similar. Let me just see you guys are reading. Momentum and those quantities are similar. Momentum is similar to those quantities, guys. Impulse. Impulse. You guys are not reading. Impulse. Momentum is what? Mass times velocity. velocity is scalar, is vector, so momentum is also vector. Or momentum is 4 times time. That's solar impulse. Force is also what? Vector. Now, if you talk about momentum, we talk about collision. We only say that it goes in the direction of the object and it does collision. Or after collision, they coalesce. After collision, they go in a separate way. Do you understand? So the direction is compulsory momentum. So momentum cannot be what? A scalar constant. Torque. When we say torque, what do we mean torque? It's the constant that you know. When we say torque, the constant that you know. When we see the schools, I'll be telling you about them. In fact, I think I've even mentioned this talk from here before. I said that torque and moment are similar. That torque is the turning effect of the force around the point. And I told you guys that torque is another name for moment of the force. So moment is what? Force times distance as well. Now you might be thinking in your head that you might be thinking that are we on the same page, guys?
Yes, sir.
So torque is the turning effect of a force about a point. So torque is discussing what? Is discussing what force. Do you understand? So torque is the turning effect. The turning effect. You might be thinking that torque, in fact, one of the very confusing questions about this torque. Because you know, moments and work are similar, but torque is a vector quantity. Torque is vector, it's not scalar. Okay. And there are reasons why it's not vector. It's not scalar, sorry. Because it rotates around this. It has rotation, and if I want to write it right like this, any quantity you write like this, you put it out here. Now this vector. But let's leave that for now. When we start resolving, kinetic energy. I think now form of energy out solar. So the answer here is I, electric potential, and IV, kinetic energy. So my answer is option D. Do you understand this? Okay, the following is a set of vectors. Set of vectors. It means that all should be vectors. Force, vector, yes. Mass, not a vector. Why? It is fundamental. Moment, vector. If we've seen one that is not vector, so we just cancel option A is not the answer. Acceleration of vector, yes. Velocity, vector. Moment, vector, yes. Mass, no. Mass, option D, no. So the correct answer is option B. Acceleration, velocity, and moment. Is there anybody here today now that is with us since we started this class and still does not understand how we are picking scalar and picking vector? Talk now or remain silent until the recordings is dropped and you have to go back and watch. Anybody? I don't understand. Just give me thumbs up. Don't be shy. Okay, you all understand. Okay, someone is saying, Caroline, you understand, right?
No, sir.
Do you understand?
No, sir.
Okay. Were you with us since the start of the class?
Yes, sir.
Okay. Why didn't you now talk? I should have talked. Now, what if I didn't ask the question? Oh, you're just patiently waiting for the recordings to drop so that you can go and watch. That's what you're doing.
No.
Okay. You see, when we say scalar quantity, I already gave you the numbers of scalar quantities that we have. All fundamental quantities. It means that here now, mass, length, time. There is a lot of controversy about time. Time, electric current. Aisha, electric current, the intensity of light, all those common points I gave you guys. This was not before my class. So all those guys I gave you, they are all what scalar. So anyone that you cannot find in this list of guys, these categories, all. So that's the speed, that's the and power, and reservation. This one, they are in the same family. Remember that we talked about these guys. Work, energy, power. Don't keep it there. Work, energy, power. In fact, you can do sweep for them, sweep, speed, work, energy, electric potential, and power. Sweep, that's very good image. That's one of the ways to learn. Sweep, if it's not part of the sweep and it's not fundamental, just leave it. So two categories now. Category one, all fundamental. Who else can hear me, please? Can you hear me? If you can hear me, please give me a thumbs up. Yusuf Lawal, you can hear me clearly. Yusuf Lawal can hear me clearly. Benny Becker, you can hear me clearly. If you can hear me, please talk. If you can hear me, talk. See, I can hear you. Talk. If you can hear me clearly, talk.
I can hear you. I can't hear you
You can
clearly.
hear me then. Then
I
that
can
means
hear
I cannot hear me. That
I
means
can't.
you can hear me talk.
It's not
Some
clear.
parts, some people
It's breaking up. It's
can
not
hear me.
clear.
This I can hear me. It's breaking or it's clear. People
I can't
can
hear
hear
what
me.
I can't hear what you say.
People that can hear you. Is it clear or is it breaking? Let's know. Let's start from there. Hello.
I can't hear what you just say now.
What can I say? Okay.
It is cracking.
Okay. It is cracking. Everybody, it is cracking. We can hear you, but it's not clear.
Yes,
It's
sir.
It is breaking.
It's cracking.
Okay, it is cracking. Everybody, it is cracking. Okay. I know what is going on. Don't worry. Babu. Don't mind my Wi-Fi name. I don't want people to join. Am I audible now? Can you hear me clear now?
Yes, sir.
Yes, we can hear it clearly
Don't
now.
mind my file name. Oh. I don't want people to join me. That's all. I use my network.
Oh, wonderful now.
Okay. So I said to make it easy, let's put it into two categories. Scalar quantities have just two categories. Category number one, all fundamental, right? So you already know what I'm talking about. I'm talking about 7 quantities. Category number two, sweep, speed, work, energy, electric potential, then power. So if it is not sweep and it is not fundamental, then it is what? Vector. Is that clear? No problem at all, Abby? I already explained the reasons why each of these guys are not fundamental. So you just need to go back to the video and watch. But you don't need to concern yourself with that. Just focus on this category. I already have to shrink it. Do you understand? So don't stress yourself. All fundamental, scalar. Sweep, scalar. Sweep is what? Speed, work, energy, electric potential, then what? Then power. So let's come back here, please. Question 5 says, which of the following is a set of vector? Set of vector. So it means that there will be some scalar inside. Let's fit out those scalar. In option A, look at mass. Mass is a fundamental quantity, so option A is not the correct answer. We'll rule it out. Option B, acceleration, velocity, and moment. These three guys are not part of sweep, and they are not fundamental. So our answer should be option B. Let's check option C. Option C adds mass, so it's not option C. Option D adds mass, so it's not option D. So the correct answer is option B. Is that clear, guys? Okay. Question 6. Which of the following is the vector? Now we're looking for vector. Remember, scalar. You already have the scalar, all fundamental and sweep. Electric charge is fundamental, so this is not the answer. Electric field, we don't know anything about it. Let's leave it. Electric potential difference, you don't know anything about it. Electric capacitance, we don't know anything about it. So this question might be a bit daunting if we are not careful. So now it will require some knowledge before we can even take the correct answer. Now, I gave you guys electric potential. Still the same thing as electric potential difference. So let's rule this out. Do you understand? You guys know electric potential now? Good. Now, when I was explaining, I explained electric field to you guys. But I explained electric field intensity, right? It's still the same thing as electric field. In fact, I drew one arrow like this, like this, like this, like this. That's the direction. It's the direction of flow of electricity. When we say electric field, field itself in physics, it's a region in space where the effect of some physical agencies can be experienced. When we say field, it's a region in space where we experience the effect of three things. Number one, gravitational. Number two, electrical. Number three, magnetism. It is a region where we experience the effect of these three guys. That's field. So if it's not direction inclined, it's direction inclined. You might experience it here. You might not experience it here. You might experience it more here. You might experience it less here. So it is talking about what? Direction. Do you understand? So electric field is what is the correct answer. Because that's the way it was. Direction. Don't forget. Electric field intensity. Electric field. Is that clear, guys? Now, electric capacitance. When we say electric capacitance, it's very easy. It has nothing to do with what's it called? With direction. So you might want to add this to your list of scalar quantities because this one is scalar. Electric capacitance is the ability of the conductor or a capacitor now to store electric charge. Is that clear? The ability of a conductor to store what? Electric charge. That's what we call what? Electric capacitance. If you on your generator starts, but light was not supplied into the house. There's no light, but the generator is actually working, and the fuse is okay. The fuse was properly connected, the wire and all of that. Most likely, what will be faulty is your capacitor. There's something called capacitor. There's something called a capacitor. So most likely what will be fault is the capacitor. So the electric capacitance is the ability of a capacitor to store what? Electrical energy. So that capacitor is responsible for storing electrical energy. Exactly. So that doesn't do with that direction. So it's also a scalar quantity. But if you know your way around this, you even not even need to go to electric capacitance. Question 7 says the following consists entirely of vector quantities. Only vector. Only vector. Only vector. You can tell me the answer to question 7 with all what we've done.
A.
Only vector. A. Okay. A. So I'm going to start from G. Only vector. Work is scalar. So it's going to be the answer. B can be, G can be the answer. I don't even need to check the C. I can see power. It can never be the answer. So say I'm taking B, I can see mass. It can be the answer. The answer is A, which is velocity, magnetic flux, and what? And reaction. Even with the fact that we don't know magnetic flux, I'm not using my mouth to explain magnetic flux to you guys. Although I've said something like that to you. I'm not using my mouth to explain that flux
Site
to you
is
guys.
cracking. Site is cracking.
It's cracking. That's what's my just to. Is it better now?
Yes, sir.
Okay. This is the network we want to use to compete with global talent. This same network, we want to use this same network to do things that people in China, people in UK, people in US are doing. So pathetic. Yesterday, totally Airtel and MTN, they went off totally yesterday. Did you guys also experience the same thing in your area? Totally. Talk. Alabama. Oh, you did not experience it. Ajaya, where are you living? I mean, that's small. Maybe you're not using Glow. It is a lot. Because here, it went off. Okay. Question 8 says, the pair of physical quantities consisting of vectors are, I don't have like, I live in there. That, okay. So, the pair of physical quantities consisting of vectors only are vectors only. Acceleration and speed. This is part of speed. So it's not vector only. B, displacement and torque. Back. C, velocity and distance. Distance, no. Momentum and power. Power, no. Distance, don't forget, distance is the same as. Okay, I think it's my data now. So the correct option is displacement and torque. It's from B. I already told you about torque. So because it's the same as moment. So it's a vector quantity. Question 9. We should follow a vector quantity. Can you see? This is question 9. I think it's the same as altitude. Vector is not a vector. Altitude is not a vector. This is vector. This is vector. This is vector. A pair of physical quantities that are scalar only scalar. Volume and area. That's the answer. Don't think for the moment I'm going to know. Length and displacement. This one, no. Impulse and time. Impulse, no. So the correct answer is volume and area. Are we together, guys? A quantity which requires magnitude and direction to be spent. There for vector quantity. Which one is the displacement? Yes.
Displacement.
See, it says, look, try to be correct. I think the textbook trying to divine vector quantity, but they went too excessive in the textbook. Seeing that quantities that when you sorry, scalar that when you add it's not Nigerian factor, guys. It's data factor. Can we continue now? Yes. Excellent. Good. When you're watching the video, when you get to that point where the network went off, just skip it sharp. If you are present in class, you'll know network one lumber. Okay. Electric potential. Where did we stop? Okay, I was explaining the interpretation that some textbooks used to give vector quantity. There's something we do in vector. If it goes in the same direction when you are resolving, you say you remove this one from this one. So they say a vector quantity can give you a negative value, but a scalar quantity cannot give you a negative value. That's wrong, though. Don't carry that definition in your head. Because temperature, we can have negative value for temperature. We can have negative value. Your temperature can read negative, temperature of a place can read negative 39 degrees. That's possible. Just like this alcohol, it has what's it called? A freezing point and all of those things. So all those negative degrees is possible. So don't take negative sign as a means to say that one quantity is scalar or vector. No, like just know the basis. The basis is that quantities that we cannot divine with direction are scalar. Quantities that we divine with direction are scalar. Look at the here. It says a quantity which requires magnitude and direction to be specified is we need those two things to be specified. They are vector quantities. Electric potential, torque, kinetic energy, momentum. Which are the following listed above are vectors? Electric potential, no. Torque, yes. 2. Kinetic energy, no. Momentum, yes. So 2 and 4.
That's how
2 and 4. Good. Thank you so much. Very welcome. When vectors are added, the result is I love this question so much. I almost mentioned this while I was explaining, but I didn't later mention it. When vectors are added, the result is scalar. No. Scalar and zero vector. No. Vector and scalar. No. When you add vectors together, you get what? You get vector. You get it. When you add scalar together, you get scalar. Do you get it? Good. We are following the vector. Question 14 and 15. Quickly, yeah? 14 and 15, type your answer. Quickly. 14 and 15, type your answer. 2 minutes. Oh. 14 and 15, type your answer. You can see somebody already failed. I didn't say you. Okay, I said type your answer. Okay. What I meant actually was type the option. Type the option, not the answer. Sorry, type the option. You guys need to pay attention to details. Like that's exactly what you need now. You have to pay attention to details. 14, C, good. The following is a vector. 14, C, velocity. Energy, low. Temperature, no. Volume, no. 15, A. So the following is a scalar quantity. You can see. Sharp, electric potential. You don't need to stress yourself. And this question was asked 2013, 2023. Electric field, no. Angular momentum, no. Linear momentum, no. Okay, that brings us to the end of everything I want to do on vector and scalar quantities. We'll still come back to vector quantities actually and talk about how to resolve vectors. But for now, I want to quickly move to motion. Motion. In motion, we are going to come across some guys. Some quantities that we are going to play with a lot. We are going to play with distance, displacement, speed, velocity, acceleration. It's important that you call it like that. Deceleration. So that you know that the stress is on the second to the last syllable. Any word that ends with T-I-O-N. The stress is always on the second to the last syllable. Education. Interjection. So we'll talk about these guys. There are some formulas that we also need to know. Let me write these formulas for you so that you can memorize them.
Sir, can we also
is equal
say as deceleration and retardation are the same thing?
Thank you so much. I will still say that actually because I'm not even talking about the guys. So retardation, they are the same. So this is equal to U plus AT. F is equal to UT plus half AT squared. V squared is equal to U squared plus 2AS. Allowance F equals 1 over 2 U plus B C. What else? We can do this for now. Now, in this formula now, I'll just quickly tell you what is inside this formula. This is I'm putting here. You must know it before I do. This formula was right. In fact, if you are ready to lazy around in this class, then that's your dream of 3 something to not come into fruitfulness. So the only solution is not to lazy around. You must not lazy around. You must not be lazy. You must not be lazy. Now, in fact, don't even think of being lazy. Don't think of being lazy. So V is final velocity. U is initial velocity. And you know velocity is what? Meters per second. A is acceleration. And unit is meters per second squared. So anytime you see meters per second squared, you already know the calculation. Anytime you see meters per second, you now accelerate this final or initial. I will tell you how to do it final or initial. I will tell you at the moment. C is our time. And that one is in seconds. You see this F? This one, the one I love the most, is distance. In what? In meters. Now you might want to ask the question that we see this V now. We see now that V final velocity V, U initial velocity, A we can say acceleration A, See, we can see time. See, but where can we see this earth as distance? My dear, that's part of the best theorem that you have to know. If I have my way of becoming the minister for education, I'm going to change some things. One of the things that I'm going to change is we using S as distance. And it is actually from somewhere. It is from somewhere. It is from X like this, which is X axis. It later became S from there. But that's how we use it. There's no choice. It's not my fault. It's nobody's fault. That's how my fathers used it. That's how my teachers taught me. I don't have power of changing it. Like I said again, if I become the minister of education, I might change it. So before we continue further, the first task is you guys must memorize this formula before the next class. Is that okay? And you must know what each and every one of these things stands for. V is equal to U plus 80, S is equal to UT plus half 80 squared, V squared is equal to U squared plus 2AS, S is equal to 1 over 2U plus V multiplied by 2. You must know them the way you know your name. So you must not mix words together. If I ask you the first, the second, the third, the fourth, the fifth, you must know them without mixing them up. Is that correct? So when we say motion now, let's come to today's motion. It is change. This one I gave you is called preamble. You guys know preamble. Have you seen those olden days Yoruba movie? In fact, there's even something better than preamble now. There's something called thriller now, right? You guys know thriller. Is it thriller like this or thriller like this? I don't even know. But there is one thing that they do before they watch. It's cracking again. It's cracking again.
Yes, sir. Yeah. Sorry, sir. Sorry, sir. Stop putting finger inside your mouth.
It's better now. Okay. So
Yes, sir.
I want to. I said everything I wrote here on my screen is called preamble. So if you've seen all those olden days Yoruba movie, you'd have seen a part whereby before they even start the movie, they will first show you one scene of one guy running and motor later hit the guy. They'll now go to the movie. That part is called what? How do you call it in illustration? So this is exactly what you have on my screen. Now, the today movies that you have now, people go to see the trailer first. Is it this trailer or this trailer? They go to see something first. That is like a summary of the whole movie. They just show you some scenes. Just like people that used to watch highlights. You not see all the whole but just watch highlights, just watch some parts. The first goal, the second goal, the best kick, the corner kick, the red card, just know those parts. Not everything. This is a summary of that's exactly what everything I gave you. Now let's come to the class. What is motion? How we say motion? Motion is change position of an object in position of an object. You can't hear me. Can you hear me?
It is cracking.
Is it better now, guys?
Yes, sir.
Okay. This network is frustrating. Okay. So when we say motion is the change in position of an object with respect to time. When an object moves from point A to point B, we say the object has undergone motion, change in position of object with respect to time. So what we are going to quickly look at now is just talk about types of motion and we'll end the class. We're going to end the class in the next 2-3 minutes. So we have types of motion. We have random motion. No, let's start with translational. Translational motion. We have random. We have rotational. We have oscillatory or vibratory motion. Number 5, we have relative motion. Okay, assignments. Go and read up on these guys and their types and their examples. Read up with examples. And we'll continue from there in the next class. Thank you so much. Our next class is on Friday.